Alright, so here you want to solve for x, and the directions that you can use any method you want. And if I were you, I would probably go with the quadratic equation, because often that is one of the most reliable ones. Often, if you're working with imaginary numbers using completing a square, sometimes you might start like missing terms. Terms might get like too big, whatnot. So over here, you see you have two of coefficients of the same x term. You want to really just sort of combine that into minus 2 plus 3i x plus, and then this whole thing, by the way, this whole thing is equal to 0, x, and then this whole thing, your whole c term would just be 3i. So if you wanted to compare this with the standard form of quadratic, it would be ax squared plus bx plus c equals 0. So each of these, that's b, this whole chunk is c, and that whole thing is a. So now when you plug this into the quadratic equation, you get x equals 2 plus 3i plus minus the square root of 2 plus 3i squared minus 4 times 1 times 3 plus 3i. Okay, and this whole thing will be over 2. Alright, you want to square this term, and then multiply 4 and distribute it to 3 and plus 3i, and then after you do that, you should get this. You should get 2 plus 3i plus minus the square root of 4 plus 12i minus 9 minus 12 minus 12i. And this is all over 2 still. Don't forget that. And when you simplify this, you will get 2 plus 3i plus minus I rad 17 over 2. So here you can see you have two possibilities. You can either have root 1 can either be 1 plus 3 plus 17, rad 17 over 2 I, or root 2 could be 1 plus 3 minus rad 17 over 2 times I. And now what I did here, essentially, I just 2 over 2 equals 1 plus 3 plus minus I rad 17 over 2. So I just essentially just did that. Which is just equal to that. So your two roots would be that. And that would be your answer.